In this video lecture, we shall see the logic and the assembly code to transfer block of data bytes from a source to destination within internal memory. Let us first discuss the logic of the program. Let's consider that we have to transfer 5 bytes of data from source to destination, right? And both the source and destination are internal memories. So in the basic version of 8051, we have 128 bytes of internal RAM. So 30H is the starting address of the source, whereas 40H is the starting address of the destination, right? So what we are supposed to do is we are supposed to transfer this block of data from the source memory to the destination memory. So for that, let me initialize some data. So I have initialized the memory locations as 1, 2, 3, 4, and 5, right? And before execution, I don't know what is the data, right? So what I'm supposed to do is I have to transfer this 1 to the destination. Then afterwards 2, 3, 4, and 5. So this is what is expected, right? So what will be the logic in the code, right? And in this program, any program we write, we should make it dynamic, because now I have considered a size of 5 bytes. So someone may consider a size of 100 bytes, right? So the program should be able to work for any number of block size, right? So for that, we shall use the concept of pointers, right? And we know that in 8051, when we write a program in assembly, R0 and R1 are used as pointer registers. Fine. So the first step what I will do is I will initialize R0 as a pointer to the source. Then I will initialize R1 as a pointer. R1 as a pointer to the destination, right? After this, I will start the transfer of the data, right? So how do I do that? I will use the indirect addressing mode, and first I will copy the first byte to the destination. So in the destination, 1 will be copied, right? Afterwards, I will increment the pointer to point to the next location. Now R0 and R1 will be pointing to the next location, right? Afterwards, I shall copy the next byte to the destination. So for this process, I shall continue unless all the bytes have been finished. So for that, I will have a loop count. So in my program, the count of the loop or the count of the block is equal to 5. Right, so I will initialize some register with this block size, and then I will repeat this process. This is the logic of this program. Now we shall proceed to see how to write the code on this. Now let us start the code, right? So whenever you write in assembly, always leave some 2 tab spaces, right? So that you can write the label properly. So I will start with org0h. So this is where my code will be stored. This will be the starting address, and this is the end directory. So my code resides between these two. Remember, org and end are not instructions, but they are assembler directives. Org indicates the start of the code, and end indicates the end of the code, right? Now the first part is initialization, right? So what should we initialize? First, I should initialize R0 to point to the starting address of the source, right? So for that, I will write move R0 comma hash 30H, and the comment will be initialize source pointer. the comment should reflect the functionality of the instruction, right? So you should not write a comment such as copy 30H to R0. So that will not be a proper comment, because R0 is acting as a pointer to memory location 30H. One of the mistakes many students do is, because we use the word memory, they don't use this hash symbol. In this case, what happens is 30H will not be copied to R0, right? The contents of 30H will be copied. So that will be wrong as per our logic. We want R0 to contain the memory location address 30H, and that can happen when we copy 30H to R0, right? Similarly, I will initialize a pointer to destination address. So this is a pointer to the destination, right? Now that the pointers are ready, now I need to copy the data now. Okay, so how will I copy? We have a restriction in 8051. I cannot use the address, the instruction like this, right? This is not allowed. Okay, so what I will do is I will first bring the data into accumulator. Okay, so this will read the data. What it will do now? Currently R0 is pointing to 30H, right? So at the rate of R0 means copy the contents of memory location pointed by R0. So R0 contains memory location 30H, and in 30H whatever is the data, that will be copied to accumulator, and this we have to send it to the destination. So I will say at the rate of R1 comma A. So this is writing the data, right? So in move instruction, whenever we copy from source to destination, the contents of the source are not altered, right? Now after you copy the first byte, what should we do now? We should increment our pointer so that we can copy the next data, right? So for that I will say increment R0 and increment R1, right? And the comment will be update pointers. And this we need to repeat for n number of times. So here our block size is 5. So we'll copy move R2 comma hash 5. So this is the block size, right? And the looping instruction will be decrement jump on non-zero R2 comma repeat. So where will be the repeat now? I have already updated the pointers. Now I have to copy the next byte. So that repeat will come here, right? So this code will be repeated for 5 number of times as we are copying 5 bytes of data, right? So once you have done your job, you should end with a forever loop. So S jump here. Done. Now we shall execute and see whether our logic is working fine or not. But before that, let's assemble this. So we have 0 errors and 0 warnings. We will go to the debug mode, right? You can close all the windows and only keep this register window and the code window. And because we have to initialize some memory, we need memory window, one memory window for the source and one memory window for the destination, right? So I will go to view, click on memory window, select the first memory window, right? I want one more memory window for destination. Go to view, memory window, the second memory window, right? And because we are dealing with the RAM, so for viewing any RAM location address, the notation to be followed is D colon the memory address. So if you type D colon 0 cross 30, it will take you to the address 30. Similarly, if you want to see the code memory, C colon 0 into 1000, so it will take to the memory location 1000. And if you want to view external RAM, so X colon, let's say 0 into Into means the X symbol in your keyboard, 2000, right? So these three things you need to remember, right? Now because I am dealing with the RAM now, so I will type D colon 0 into 30, right? And the destination is D colon 0 into 40, right? So you can see this is memory location 30, 31, 32, 33, 34, right? So 5 bytes. And initially all the locations have 0. So I need to initialize this memory location with some data. How do I initialize? There are two ways. One is you can double click here and say 1 and click and say 2. The other way is you click on the starting address, right click there and click on modify memory at D colon 0 into 30, and then you type 1, 2, 3, 4, 5. Okay, so you can enter in decimal as well as in hexadecimal. So this is the way to enter a decimal number. Okay, so if you click, the first 5 memory locations have been initialized. Now we shall execute now. The first instruction will initialize R2 with a count of 5. So R2 has become 5. Next, initialize the source pointer. R0 will contain 30H. R1 will contain 40H. Right? And whatever is there in memory location 30H, which is pointed by R0, it will be copied to accumulator now. So A will contain 1, right? And this one has to be copied to the destination. So destination is 40H, which is pointed by R1. So if you execute, you can see the first byte has been copied. Now we need to update the pointers. So we will increment the pointers. R0 is incremented by 1, so it has become 31. It means it is pointing to the memory location 31H. Similarly, R1 is pointing to memory location 41H. What should we do now? Again, we have to copy the data. Right? So 2 has come to the destination. And this process will repeat until R2 becomes 0. Right? So you can see R2 is still 4 because we have copied only 2 bytes. So you can see the data being copied one by one. Now R2 has become 1. Now if I decrement, R2 will become 0. So this instruction checks whether R2's contents are 0 or not. Right? If it is non-zero, it repeats the loop. But if it is 0, it comes out of the loop. And currently R2 is equal to 1. So when it decrements R2, it becomes 0, and this jump on non-zero condition fails. Right? So it will come out, and you can see all the 5 bytes have been copied. So this is the logic and the assembly code and the execution part for the first program, that is to transfer a block of data from source memory to the destination memory. Thank you.